Hi guys, how are you? I hope you and your family are doing well. So today I'm going to talk a little bit about section 6.2. Okay, that's binomial probabilities. Okay, so let me start with a definition of binomial experiments. So what's a binomial experiment? Well, a binomial experiment, that's an experiment with only two possible outcomes, either success or failure. So that's an experiment, and there are two possible outcomes. So either success, okay, I'm gonna denote success by capital S, or failure, and I'm gonna denote failure by F, capital F. Okay, so we have an experiment, and there are only two possible outcomes. Either you have success or failure. I'm gonna denote by P the probability of success. So P, that's probability of success. Okay, and Q, that's probability of failure. Okay, so again, P, that's probability of S, so that's probability of capital S, probability of success, and Q, that's probability of capital F, so probability of failure, right? Now, so for example, let's say you have one multiple choice question. Okay, you have a just one multiple choice question. Okay, and let's say you have four choices. So with four choices. Okay, so you have this experiment where you have to answer, so you have to answer this multiple choice question, right? That's your experiment. Now, of course, if you answer correctly, so that will be a success. And if you get wrong answer, of course, that will be failure, right? So now, so what will be the probability of success? So what will be P? Well, probability of success, P, is to answer correctly the question, right? So now you have four choices. There is only one correct answer out of the four choices. So probability of success, P, probability of success, that's, so we have one correct answer out of four choices. So that's 1 over 4, which is of course 25%. Okay, so probability of success here is 25%, again, because you have four choices and there's only one correct answer out of 4. Now, what will be the probability of failure, or probability of capital F? Well, there are 3 wrong answers, right, out of 4. So that's 3 over 4. And so that's 75%, right? That's 0.75. And so that's just 75%. Okay, so your probability of success is 25% because there is only one correct answer out of 4. And probability of failure, that's 75% because there are, three wrong answers out of 4, right? Now, in general, in this binomial experiment, the goal would be to find the probability of are successes out of, so the question now is, what's the probability of R successes out of n trials? Okay, so for example, let's say now you have not just one multiple choice question, but let's say you have two multiple choice questions. Okay, so we have two multiple choice questions, and again you have four choices. Each question has four choices, right? And again, when you answer one question, the probability of success is probability of success, so P is, we said, it's 25%, right? Because again, you have four choices, each question has four choices, and there is only one correct answer, right, out of four, so that's 25%, and probability of failure, that you get the wrong answer, that's 75%. Now, because we have now two multiple choice questions, not just one, we have two questions, right? We can ask, what will be the probability? What's the probability to get zero right answer? To get zero right answer. So you're gonna answer. So we have two questions, right? You're gonna answer the two questions, and now we want to determine the probability to get zero right answer, right? We can also ask, what's the probability to get one right answer? One right answer out of the two questions, right? You have two different questions, and we want to determine the probability to get one right answer. Now, what's the probability to get two right answers? Two right answers. Okay. Well, first, let's see. So first, what's the number of trials here? What's n? N, remember, that's the number of trials. Well, because we have to answer two different questions, right? So that means that you have two trials. So number of trials, that's the number of questions. That's two, because we have two questions to answer, right? Okay, now, what are the possible outcomes? Well, first, well, you can answer correctly the first question, right? So let's say you answer correctly the first question, so that's an S, and you answer also correctly the second question, so that's another S. Okay, so when I write SS, it means my two answers, so I answered the two questions correctly, right? So two correct answers. Or you can, answer correctly the first question, so that's a success in the first question, but you fail in the second question, so that's a capital F in the second question, right? So we have now S and F. So S because we answered correctly the first question, and F because we failed the second question. So S, so we that's S first question, and F, we got F in the second question, right? We failed the second question. Or we can fail the first question, right? And we can succeed to answer correctly the second question. So in this case, we have an F in the first question. And we succeed to answer correctly the second question. So we have an S in the second question. The last case is when you fail the two questions. So when you get two wrong answers. So we get F in the first and we get F in the second. So that's two wrong answers. Okay. So now, what would be the probability to get a zero right answer? So zero right answer. Well, that's when you fail the two questions, right? So that's the probability of F and F. So you fail the first and you fail the second, right? So probability of F and F, fail the first and fail the second. That's the probability F, and F, so we are using and, so that will be a multiplication. So that's the probability of F times probability of F. The two events are independent, so we just multiply the two probabilities. P of F times P of F, so what's P of F? We said that's probability of failure, so that's Q times Q. And Q in this case, we said it's 0.75. Right? That's the probability that you fail the first question times 0.75. That's the probability that you fail the second question. Right? So 0.75 times 0.75. So the answer would be 0.5625. Okay. Now, what would be the probability to get one right answer? One right answer. Well, there are two possible cases. Well, either, so probability to get one right answer, so there are two cases. Either you succeed to answer correctly the first question and you fail the second question, or, okay, so we are using or, you fail in the first question and you succeed in the second question, right? And because we are using or, so that will be addition, right? So that's probability of to succeed in the first, fail the second, plus, because of or, okay, this is because we have or, the probability that you fail the first and you succeed in the second, right? Now, probability to succeed in the first and to fail the second, so that's probability to succeed in the first times probability that you fail the second, plus, now probability that you fail the first time and you succeed the second, that's the probability to fail the first times probability that you succeed in the second question. So again, probability of S, probability of success, that's P, and probability of failure, that's Q. So that's P times Q plus, this is Q times P, all right? So the P, that's the 25%, and Q, that's the 75%. So again here, Q, that's 0.75 times 0.25, all right? And the final answer, so that would be 0.1875 plus 0.1875. So that would be 0.3750. Okay, so that's the final answer. Now, what would be the probability to get two right answers? So two right answers. So that's when you succeed to answer correctly the two questions, right? So that's P of S and S. You succeed in the first and you succeed in the second. So that's the probability of S and S, so that's the probability of S times the probability of S, because we have success in the first and success in the second, so we use multiplication. So now probability of S, probability of success, that's P, times probability of success, that's P. So P, again, that's 25%, times 0.25%. So that's actually equal to 0.625. 0.0625. Okay. Okay, guys. Let me first remark here, important remark, that probability of of success plus the probability of failure, it's always equal to 1. So P of S plus P of failure, this is always equal to 1. In other words, P plus Q is equal to 1. Like in our example, we said probability of success, that's 0.25, and probability of failure was 0.75. That's equal to 1, right? Okay, now in general, if you have, so we have a formula to compute actually the probability of our successes out of n trials. So the general formula is the following. So let's say you have n, that's the number of trials, R, that's the number of successes, okay, and then P, that's probability of success, probability of success, okay, and then Q, that's probability of failure, okay, then the probability of our successes is always equal to, so P of R, that's the probability of R successes out of n trials. Okay, so that's actually equal to, well, I'm gonna first use a symbol. There's a symbol C index NR times P to the power R times Q to the power n minus R. Okay, now first, what's this C index NR? So that's the symbol for n choose R. Okay, so n choose R, that's the number of ways to choose R objects from n, okay, where order doesn't matter. So this n choose R has a formula. So this n choose R, we can also denote it like using like parentheses, then there's n in the top and R in the bottom, and that's always equal to n factorial over R factorial times n minus R factorial. Okay, so let me explain what's the factorial. So here the factorial, so what's the factorial here? Well, when you say n factorial, that's actually this is actually multiplication, so we have to multiply 1 by 2 by 3 times 4, etc. until, and you stop at n actually. Okay, so for example, when you say 4 factorial, so that will be 1 times 2 times 3 times 4, so that's 24. If you say 3 factorial, that's 1 times 2 times 3, so that's 6 factorial. If you say 2 factorial, that's 1 times 2, which is 2. If you say 1 factorial, that's 1. And if you say 0 factorial, so by convention actually, so 0 factorial is actually equal to 1. Okay. Now, so let me write again the formula and let me apply it again to our example with the multiple choice questions. Okay. So again, the formula is, so P of R is, we said we have this n choose R. So to compute this n choose R, you can check your calculator. There's this symbol, symbol with the capital C and the index NR. Okay, so you can use a calculator to compute this n choose R. So first, you have to use your calculator. You can use your calculator, or you can also check your textbook. There is an you can find like in the appendix of the textbook, you can find the formula for this n choose R. But anyway, so let me write again the formula. So we said the probability of R successes, that's n choose R times P to the R times Q to the n minus R. Okay. So, for example, well, let's say now we have 4 multiple choice questions. Okay. And again, each question has 4 choices. So the question is, what's the probability to get 2 correct answers? Two correct answers. Okay, so first, guys, so step 1, let me just write down in the first step 1, what's P, Q, N, and R. So in the first step, you have to write down what's P, Q, and N, and R. So first, N, what's the number of trials here? Well, we have 4 different questions, right? So number of questions or number of trials is 4, because we have 4 different questions. Now, what's R in this question? Well, R must be, what's the probability to get 2 correct answers? So number R, that's the number of successes, right? So the number of successes in this case would be 2, because the question is, what's the probability to get 2 correct answers? So the number of successes is 2, right? Now, what's P? What's the probability of success? Well, again, probability of success. So there are 4 choices to, there's only 1 correct answer out of the 4. So P of the probability of success, it's 1 over 4. Again, that's 25%, right? Because there's only 1 correct answer out of 4. Now, what's the probability of failure? Well, that's 3 over 4, right? That's the 75%. Now the question, now we can, in the step 2, we can answer the question, what's the probability to get 2 correct answers? So that's the probability that R, the number of successes, is 2, right? So if you use a formula, so we have N choose R, so N is 4, choose R, so R is 2, and then P, right? P is 0.25 to the power R. R is 2, so square here, times Q N minus R. So that's 4 minus 2. So that's 4, sorry. So that's 4 minus 2. Okay, so now what's 4 chose 2? Again, guys, you can use your calculator. There's this symbol with the C index and R. So if you want to compute C index and R, and choose R using your calculator. So first you type 4, then you type the C index and R, and then you type 2 on your calculator. Okay, or you can just use a formula. So this is 4 factorial over R factorial, so that's 2 factorial, times n minus R, so that's 4 minus 2 factorial. So 4 factorial, that's 4 times 3 times 2 times 1. 2 factorial, that's 2 times 1. 4 minus 2, so 4 minus 2 is 2, so that's 2 factorial, so that's 2 times 1. Okay, so that's 24 in the top, and then 2 times 2 in the bottom. So that's 24 over 4. So that's equal to 6. So 4 chose 2 is equal to 6. So now I can answer the question. So P of R equal to 2. So that will be 6 times the 0.25 square times the 0.75 square. Okay. Or, so that's 6 times 0.25 times 0.25 times 0.25 times 0.75, sorry, 0.75. Okay. And okay, so now another question. So that's first example. Now another example, again the same. So example 2. Okay. Again, let's say we have again 4 multiple choice questions. Okay, with, let's say each question has, let's say 5 choices. Okay, so, and the question is, what's the probability to get let's say at least 3 correct answers? So first, step 1. Let me again, the step 1, we're gonna write down what's N, what's R, what's P, and what's Q in this example. So N, so how many trials? Number of trials, again, you have, that's the number of questions. We have 4 questions, so the number of trials is 4. Now, what's R here? What's the number of successes? What's probability to get at least 3 correct answers? So the number of successes here is at least 3, okay? Well, of course, so R is at least 3, okay? So which means that R is 3. Of course, we have 4 questions, so R is 3 or 4, okay? So to get at least 3 correct answers, it means you get 3 correct answers, or you can get also 4 correct answers, right? You have 4 questions. So R is 3 or 4. Now, what's P, probability of success? We have 5 choices. There is only one correct answer out of 5, so that's 1/5. So that's 0.2. And probability of failure, of course, out of 5 choices, there are 4 wrong answers, so that's 4 out of 5. And that's 0.8. That's probability of Q. Now, to answer the question, so probability that R is at least 3, we said that that means that R is 3 or R is 4, right? If you have at least 3 correct answers, it means you have 3 answers or you have 4 answers, because we have 4 questions, okay? So, because we have this word or, so we're gonna use addition, so P of R equal to 3 plus P of R equal to 4, okay? Again, plus because we have or. Now, what's P of R equal to 3? So we're gonna use the formula. So N is 4, right? We said N, the number of trials. We have 4 different questions, so N is 4. So R is 3, so we have 4, choose 3. So 4, choose 3 times probability of success, that's the 0.2 to the power R, R is 3, times probability of failure, that's 0.8 to the N minus R. N is 4 and R is 3, so 4 minus 3, okay, plus, so this first part, this is the probability that R, the number of successes, is 3. Now, number of successes is 4, so that's R is 4, N is 4, so that's 4 choose 4 times probability of success, P to the R is 4, times the probability of failure, that's the 0.8, to the N minus 4. N is 4 minus 4. So, well, 4 choose 3, that's 4 factorial over 3 factorial N minus R, so that's 4 minus 3 factorial, so that's 1 factorial, times 0.2 cube times 0. So we said 4 minus 3, so that's power 1, plus 4, choose 4, so that's 4 factorial over 4 factorial, 4 minus 4, so N minus R factorial, so 4 minus 4, that's a 0 factorial, so we have here 0 factorial times, so 0.2 to the 4, and times 0.8 to the power 0. Now, 4 factorial over 3 factorial, so that's actually this thing here, this is going to be equal to 4 times the 0.2 cube times 0.8 plus this thing here, 4 factorial over 4 factorial times 0 factorial. 0 factorial is, we said it's 1, so this is actually going to be equal to 1 times 0.2 to the power 4 times 1. Okay. And then you have to compute this whole thing here. Okay. Anyway, guys, I'm going to stop here. I'm going to continue next time with more examples, I guess. And in the lecture notes, you can check the lecture notes. There are going to be also more examples, and I will post probably extra videos with more explanation. Okay, so let me just stop here, and I will continue next time with more examples. Bye.